Now first is going to be a link. So it's a pointer, but not a pointer to struct my pile, a pointer to a node, if you remember what a link is. In this case, it's going to point to the first card in the pile of cards. Now this is quite convenient, because you'll probably see straight away, if we use a struct to represent a pile of cards, and we want to change which card's at the top, we just have to change one of the fields of the struct. We don't have to change which struct it is. We can keep the same struct and change its contents, and that will let us point to a new top. So now, with this extra level in direction, it's easy to modify the top as well as the other cards in the pile. And size, well in this case we'd store 2 there because this pile of cards has 2 elements in it. Sure, we could travel through the pile of cards of this chain of nodes here to count how many elements there are, and so we could always work out the size, but because we're a bit lazy, we'll actually save the size here, and that'll save us having to work it out every time. It does give us a little bit of extra work. Every time we add or remove a card from the pile, we have to update size, and when we initialize the pile, we have to make sure it starts off with the correct initial value. But we'll find that we probably change the structure of the pile less frequently than we want to find out its size. So recording the size like this, caching it in this way, will actually save us a bit of time and effort. Okay, so is this going to be a pile of cards? You'd be forgiven for thinking so, because we certainly have a lot of types here. But actually we need one more level of complexity, which is a pointer to this. Now I'm drawing it black because it's a pointer to struct my pile, as opposed to this blue arrow of type link, which is a pointer to a blue box. A pointer to a struct my pile is in fact what we're going to call a pile of cards. Why are we saying a pointer to this struct my pile is a pile of cards, rather than saying the struct itself is a pile of cards? Well, think for a second, you might be able to work that one out. It's something we talked about in lectures. If we pass this into a function, and the function wants to change the pile of cards, it can't change this thing here, because anything passed into a function can't be changed inside the function, or rather it can be changed inside the function, but because it's only changing a copy, it won't change the thing itself. If we want to be able to pass things into a function and have the function change them, we must pass in a pointer to those things. So it's very convenient to have a pointer to this struct. We'll pass the pointer in whenever we want to pass in a pile of cards, and then without changing the pointer, anything in the pile of cards can now be changed. Okay, so hence we have a pointer to a struct my pile containing a pointer to a node containing a card, and a pointer to another node, and a card containing a value and a suit. Might seem complicated, but actually it works out pretty convenient when we use these things. Now, you are probably wondering next how we came to define these different types in different locations. Why aren't they all whacked in one spot? You'll notice that some of them are defined in pile of cards.h and some of them aren't. They're all defined somewhere in pile of cards, either in pile of cards.c or pile of cards.h, but some of them aren't in the .h file. Some of them are defined in the C file, and some are defined in the H file. Have a look now at the code to see which ones are defined in which location, and then I'll explain why. Excuse me. Stupid cold. Alright, basically the rule of thumb is pile of cards.h is included in pile of cards.c, so anything that we define in there, those definitions can be used by pile of cards.c. The reason we want to put it in a .h file though is that other files can import pile of cards.h, can include them, hash include them. So anything that we'd like to share with other files, anything we'd like to type into other files and are too lazy to type it in each time, or too worried we'll make a mistake, we could put it in pile of cards.h and just hash include pile of cards.h, and the other files get it magically, automatically. So what things from pile of cards.c or h would we want other files to be able to see? Well, a pile of cards is a type that we've created that we'd like other functions, other programs, other files, other things to be able to use. For example, in this assignment, the program that plays clock patience needs to be able to access pile of cards. Also, the file that defines a function to shuffle cards needs to be able to see pile of cards.h. And the program file, play one game and play many games, they need to know about cards and piles of cards, so they need to know about the contents of pile of cards.h. And we could write another game tomorrow. Maybe I could ask you to write a program to play 500, or psychological jiu-jitsu, or memory, or hearts, or 500. And any programs that wanted to play those games, we don't want to have to redefine pile of cards each time. We just want to reuse the same pile of card type that we've developed for the clock patience assignment. No point in making a new one every time. There's a perfectly good, nice general one we've made for the clock patience assignment. So we'd like all those other programs to be able to use the definitions and the functions in pile of cards.